Let's continue to another lecture, which is another subsection, which is design of transmission of shaft. In the design of transmission of the shaft, the power for transmission and rotation speed of the shaft is two important specifications that needed to be fulfilled. Here, the design engineer is required to choose the right material and determine the right diameter of the shaft to ensure that the shaft is not fail when subjected to a maximum shearing stress during at which the shaft is being used to transmit the required power at a specified rotational speed. The relationship between power P and torque T is given by P is equal to torque times angular velocity omega, in which that omega is angular velocity in the unit of radian per second, and it is equal to 2 times pi times f, in which that f is frequency and the unit is per second but called as hertz. Substitute equation 3.5 into equation 3.14 into 3.14, you will get the value is P is equal to times omega is 2 pi f. You will get this. You will get this equation. The unit of power in SI is Newton times meter over second, or typically written as watts. So watts is equal to Newton m per second. The torque T can be found from equation 3.16 and become torque is equal to a power over 2 pi f, which is this one. Okay, from equation 3.10, shear maximum, you know that shear maximum is equal to torque times radius maximum over J, Tc over J. And you also know that for solid shaft, J is equal to 1 over 2 pi C to the power of 4. And for hollow shaft, J is equal to 1 over 2 pi C2 to the power of 4 minus C1 to the power of 4. Okay, so if you simplify this, if you simplify this equation, so J, you bring J to here, and then C to here, and then you bring this shear max to here, so you will get J over C equal to torque over shear max. So you have to cross the equation, so you will get this. Okay, for this one, if you bring C, 1C to this side at the bottom, you will get J over C is equal to 1 over 2 pi C to the power of 3. Okay, so this J over C is actually same as this. So this J over C is equal to 1 over 2 pi C to the power of 3, or is equal to T over shear max. So that's why you get this. So in the case of solid shaft, so in the case of hollow shaft, so if you multiply this 1 over 2, because you want to make this J become J over C, like this, J over C. So you have to multiply this 2 with C. So if you multiply this with 1 over C2, so we take the maximum radius. So this one also you have to multiply with 1 over C2. So you will get J over C2. This one also you get 1 over 2 C2 pi C2 to the power of 4 minus C1 to the power of 4. Okay? Because you multiply this with C2. And this side also, if you multiply here with 1 over C2, you multiply this side at the left side also 1 over C2. So you will get this equation. So that is why you got this equation here. And you know that J over C as this one, which is radius maximum, is also equal to torque over shear max. Same like this. So that's why this one, 3 is actually the same. So that's why you got for hollow shaft this one. Okay. So let's go to this example. A motor is operating at 4 kilowatt of power with a rotational speed of 4,200 revolution per minute and connected to a shaft which can be subjected to maximum shear stress of only 70 megapascal. What is the appropriate diameter of the shaft that should be used to meet this condition? So the question is, what is the diameter? So diameter is equal to radius times 2 or C times 2. So in here it says that okay, so we know that power is equal to 4 kilowatt, which is 4,000 watt, or 4,000 Newton meter second. And then frequency is equal to 4,200 revolution per minute. So you can convert this 4,200 revolution. So one revolution is equal to 60. So in 1 hertz is equal to 60 revolution per minute. So this you will get 70 second, the frequency. So the frequency is equal to 70. So from, and then it has been given that the allowable stress is 70 MPa. The shear maximum means the allowable stress is 70 MPa. So from equation, torque is equal to P over 2 pi F. P is 4,000, 2 pi times F, which is 70. So you will get 9.995 Newton meter. This is torque. So if we substitute torque and shear maximum into equation 3.18, so it becomes J over C is equal to torque over shear maximum. So torque is 9.095 Newton meter over, this is 5, over 70 megapascal. Mega is 10 to the power of 6. And you will get 130 mm cubic. Okay. And for a solid shaft, you know that previously J over C is equal to 1 over 2 pi C3, or this is equal to, J over C is equal to torque over shear max, in which that torque over shear max is this value. So this torque over shear max is equal to 130 mm to the power of 3 is equal to 1 over 2 pi c to the power of 3. So C is equal to, you will get 4.35 mm. And then the diameter is equal to C times 2, which is 4.35 times 2, which is equal to 8.71 mm. Okay. So therefore, you take diameter is equal to 9, round up to the nearest diameter. Okay.